We're going to take the region bounded by the function y equals square root of x, y equals 0, and x equals 1, and we're going to rotate it about the y-axis. And we want to find the volume by cylindrical shells. First step is I'm going to graph this so I know what the region looks like. We have y equals square root of x. We have y equals 0, which is the x-axis, and x equals 1 is the vertical line, x equals 1. We have this region bounded by all three curves. Next step is I'm going to put the typical rectangle, and we make note that with cylindrical shells, the typical rectangle is parallel to the axis of rotation. So subdividing this from 0 to 1 into n subintervals, I put in a typical rectangle. Right away, I know that this will be dx. To work this, I'm going to use my shortcut that the volume is 2 pi, the distance of the typical rectangle from the axis of rotation, and then the height of the rectangle, and this is dx. So the distance will be d and the height of the rectangle h, from A to B. So now I just need to see what d and h are. D is the distance from the axis of the typical rectangle, but this distance I can see is just x. H represents the length of the rectangle. H is the y value on the curve, which is square root of x. Following this shortcut, I can see that the volume is 2 pi, the distance from the axis, times the length or height of the rectangle, dx. The distance is x, and the length of the rectangle is the y value, which is square root of x, and we had subdivided from 0 to 1. And I know I can finish this and work that through. Now what we're going to do, everyone, we're going to take the same region, only this time we're going to rotate about the line x equals 1. For this, I'm going to put the region again. I had y equals square root of x, y equals 0, x equals 1. We had this region. For this problem, we didn't put it first, but it's quite easy to see that if I let x is 1 and y is square root of x would be square root of 1, so this ordered pair is 1, 1. The key is to now create a rectangle parallel to the axis of rotation. So my typical rectangle is parallel to the line x equals 1. Just like we did for the other, I need d, the distance from the axis of rotation, which becomes this value here, and then I need h, which is the height of the rectangle. The distance from the axis of rotation is 1 minus x. The reason for that is you went out 1 and then you subtracted the x value. Now the height of the rectangle, it's on the y value of the curve, so it's just square root of x. We're now ready to set up the integral. Setting up the integral, the volume is 2 pi, the distance from the axis of rotation, the height of the rectangle dx from 0 to 1. Putting in the distance, we had 1 minus x, and the length of the rectangular height was square root of x. And I know you can figure this out. Now I'd like to take this same region, only this time I'm going to rotate about the x-axis. Working this through, I put the region again. Y equals square root of x, y equals 0, x equals 1. We've got our shaded region. Only now our rectangle, our typical rectangle, is parallel to the x-axis, so it is horizontal. So we have our typical rectangle looks like this. Whoop. So for this one, the distance to the axis of rotation is the distance up. It's the y value. And h is the length of that rectangle, which is 1 minus the x value on the y. So h is 1 minus the x value, which is 1 minus the function of y. So looking at y equals square root of x, it's 1 minus x becomes y squared. Going to the next page, what happened here, the x value, because we're dealing with y equals square root of x, I had to square both sides, and that gave me that x was y squared. So that's why we have y squared here. So now I'm ready to put the volume. So the volume is 2 pi times the distance from the axis of rotation times the length of the rectangle. And because this was a horizontal rectangle, it was dy. And that was from 0 to this point up here, which was 1. Putting in d was y, and this was 1 minus y squared for the height of the rectangle. And I know you can finish that. Our last example, we're going to take this same region, only this time we're going to rotate about the line y equals negative 2. We're going to graph the region again. Y equals square root of x, x equals 1, and of course the x-axis. This time we're rotating about the line y equals negative 2. I shade my region. For this one, my typical rectangle once again is horizontal. So for this, we need, this is d, and I have to figure out the distance from that axis of rotation. So d is y minus a negative 2, y plus 2. And now h, the length of that rectangle, we had just done that, and that is 1 minus the x value, and 1 minus the x, but x was y squared. Finishing this, we get that the volume is the integral of 2 pi. The distance from the axis is y plus 2. The length of the rectangle is 1 minus y squared dy. And of course from 0, and because the point was 1, 1, it went from 0 to 1. And of course we can finish this.